Good morning, my beautiful learners. That is Tshaka, your physical science educator from Etsa Educational Project Center of Distinctions. So today, my beautiful learners, I'm just going to continue with vectors. Please do make sure that you visit our Facebook page by the name of Etsa to get the first part of vectors. And then for now, since we are preparing ourselves for final examination, I'm just going to deal with the exam type question. And please do make sure that with you do have the calculator, the ruler, the pencil, and your examination guideline. Okay, so now let's get started. Question 2. The diagram represents three forces that act at the same point on the Cartesian plane. The magnitude of F2 and F3 are 20 Newton and 10 Newton respectively, while the vertical and horizontal components of F1 are 7 Newton and 4 Newton respectively. And then before we can go back to the questions, I would like us to draw the free body diagram using the components method. Or before that, I would like us to assign or to put the values next to the resultant of forces that are provided on our diagram. So like for instance, the F2 and F3 are 20 Newton and 10 Newton respectively. So where is F2? Here is my F2. My F2 is equivalent to 20 Newton. And then my F3 is equivalent to 10 Newton. And then for F1, I am provided with two components, which is the vertical one. The vertical one is equals to 7 Newton, and the horizontal one is equals to 4 Newton. So my beautiful learners, one thing that I want us to do before we can attempt the questions, let us try to resolve all the forces that are not on the Cartesian plane into their components, so that we can have the forces that are moving horizontally, and then so that we can also have the forces that are moving vertically. The F2 is already sorted because of it is exactly on the line, but my F1, we are given the vertical and the horizontal components, so meaning we are okay. So one other thing that I want us to do, I want us to resolve this one into its components. So now let's check. Here is my dot. Okay. I'm having my F2 here. My F2. And then I'm having also the F1. The horizontal component of F1, it must be facing in this way. So I'm going to have this one, let me just name it F1 vertical, and I'm also going to have F1 this one is horizontal, I'm sorry. I'm also going to have F1 vertical. Okay, so now let me resolve this one into its components. If I'm resolving this one into components, remember that when we were busy dealing with the tail-to-tail method, I'm going to have the other force facing downwards, which is the vertical component of this force. So this one I'm just going to name it F3 vertical, and then I'm also going to have this one, which is F3 horizontal. So now my Cartesian plane, all the forces are either on the x-axis and then other forces are on the y-axis. So this is the Cartesian plane that I'm going to work with when I perform my calculations. So please, my beautiful learners, before you attempt any questions, please do make sure that you know how to resolve your resultant into its components, or you can draw your resultant or the forces that are given on a diagram, either on the x-axis or on the y-axis. So that is the first step that we must all do. We must be in a position of knowing how to draw the free body diagram like in this fashion, because of it was given in this way, but I did try to put all the forces either on the vertical lines and the vertical line and horizontal line. So please be in a position of knowing how to do what I did on my sketch. The first question that we are coming across for 2 marks, which is 2.1, we are asked to define the term vector. My beautiful learners, there is a difference between a vector and a resultant vector. When I was talking about a resultant vector on my first video, I said a resultant vector is a single force that has the same effect as 2 or more vectors together. But now the question is, define the term vector. Vector is defined as a physical quantity, that has both magnitude and direction. A physical quantity that has both magnitude and direction. So you will get your 2 marks for just writing a physical quantity that has both magnitude and direction. And then the second question that we are coming across, calculate the following: the magnitude of F1. Remember, for F1 we were given the vertical component of F1 and the horizontal component of F1. The vertical component of F1 was given as 7 Newton, and the horizontal component of F1 was given as 4 Newton. Here is my F1. And then let me just put an angle here, the angle of 60. This side is the opposite side. This one, okay, let me just, I'm sorry, the magnitude are not the same, but I just want to show you something. This side is the opposite side, and then this one is the adjacent side. This side is equivalent to 7 Newton, and then the other one is equivalent to 4 Newton. This one is F2, is 4 Newton. So now I'm having the opposite side, I'm also having the adjacent side. This side, which is F1, is our hypotenuse side. And then obviously in this situation, if I want to determine the hypotenuse side, obviously I will employ the theory of the theorem of Pythagoras theorem, which is Fr is equals to square root of fx squared plus fy squared. This is 2.2.1. And then what is the value of fx? The value of fx is this one, because of it is on the x-axis. So the value of fx is 4 squared plus the value of y is 7 squared. So now let us put everything on our calculator. 4 squared plus 7 squared, and then square root of everything. I get something like 8,06 Newton. 8,06 Newton. So meaning that is the magnitude of F1. The magnitude of F1 in this situation is 8,06 Newton. Okay, so for now let us go to 2.2.2. Calculate the vertical components of F1 of F3. Calculate the vertical components of F3. Where is F3? Here is F3. Obviously, my beautiful learners, if I want to calculate the vertical component of this one, I'm going to use the formula F vertical is equals to F sine theta. And then now, what is the magnitude of F in this situation? The magnitude of F for F3 is 10 Newton. So 10 sine, what is the angle? The angle that is given to us there is 30. So please, my beautiful learners, if you want to use this equation at all times for determining the vertical component, do make sure that the angle is measured from the x-axis. Meaning, if you really want to benefit from using this equation each and every time when you calculate the force vertical, please do make sure that the angle that is given is measured from x-axis. I hope it's clear. So now 10 sine 30 gave us something like 5 Newton. But now if we were required even to include the direction for this one, it must be downwards. It must be downwards. Okay, let us go to 2.2.3. We are now required to calculate the magnitude of the resultants of F1, F2 and F3. We are required to determine the magnitude of the resultant of all the forces. But my beautiful learners, it is quite clear that according to our free body diagram, I'm having 3 forces that are acting on the horizontal plane, or that are acting horizontally. Is this one, is this one, and then is this one, meaning I have about 3. And then vertically I have about 2, is this one and this one. So the first step that you must do is to determine the resultant of x, or is to determine the resultant of horizontal. And then the second step is to determine the resultant for the vertical. So let us start first by that one of horizontal. Let us determine the horizontal resultant for x. Okay, so F resultant horizontally is equals to, how many forces are acting horizontally here? I have about 3. So I'm just going to put F1 plus F2 plus F3. So now direction is also important. The forces that are facing to the right, let us take them as what? As positive. And then the one that are moving to the left, let us take them as what? As negative. Even the forces that are moving upward, let us take them as positive. The one that are moving downwards, let us take them as what? As negative. Okay, but for now I'm just going to focus on the horizontal forces. So let me take this one first. The magnitude of F2, it was given on our diagram as 20. So that 20, it must be what? Positive. Why positive? Because of it is moving to the right. And then plus the F2. The F2, let me take this one, because of it is also moving to the right. Remember, this F is the horizontal component of F1. So I'm just going to put 4 plus what is the magnitude of F horizontal for this one? Actually, we have never calculated it, this one. So without any waste of time, let me just do it here. F horizontal is equal to F cos theta. And then what is the magnitude of F for this one? Is 10. So it's 10 cos the angle given is 30. So now when I press my calculator, 10 cos 30, I get 8,66 Newton. 8,66 Newton. But now check the direction of this F3H. It's not in the same direction as those. So meaning for the fact that this one is pointing to the left, we are going to put this one on our calculator as what? On our calculations as what? As negative. So it's positive into negative 8,66 Newton. Okay. So now, what is our resultant for X, for horizontally? So I'm just going to say 20 plus 4 minus 8,66, and then I get 15,34 Newton. What is our direction here? For the fact that our answer is positive, we can say that the resultant for horizontal must be pointing to the right. I hope we are together, guys. So step number 2, let me determine the F resultant for vertical. How many forces are acting vertically here? How many forces are acting vertically here? I have about 2, which is F3 vertical and F1 vertical. Remember that F1 vertical, for the fact that it's pointing upward, we are going to put it as what? As positive. And then this F3 vertical is pointing downwards, we are going to take it as what? As negative. So I'm having 2, so which is F1 plus F2. It doesn't matter on whether you write F3, F2 and so forth. It will depend on how you understand it. So now my F1, let me take it as what? As 7. So my 7 is going to be positive plus into, what is the value of F3V? F3V obviously is this one that we have calculated here. We are going to say is negative 5. So now 7 plus into negative 5, our answer is going to be 2 Newton. For the fact that our answer here is positive, obviously our direction is going to be up or upwards. So now I have the resultant of X. I also have the resultant of what? Of Y. So now, my beautiful learners, when we get to this point, I will encourage you to draw the free body diagram for the second time. But the free body diagram is going to put only the resultant for horizontal and the resultant for vertical. I hope you understand. So now let us check. Here is my dot. For horizontally I have this one is F resultant horizontally, which is equivalent to 15,34 Newton to the right. And then I'm also having this one, which is 2 Newton. This one is F resultant for vertical, which is 2 Newton upwards. So for now, let us determine the resultant of the resultant. So now I'm just going to determine this one. We must determine the resultant, which is this one now. So obviously, let me put my angle here. Each and every time when I want the angle, I will always measure the angle from the x-axis. So now this side is equivalent to 2. This side is 2. This side is 15,34. The value for this side is also 15,34. The value for this side is 2. So meaning this shape is the same as the shape of a rectangle. Two opposite sides of rectangle are equal. So now, my beautiful learners, we are required to determine the F resultant. We are required to determine the F resultant. So now, in order for us to determine the F resultant, obviously we must be in a position of knowing how to use the theorem of Pythagoras. We must be in a position of knowing how to use the theorem of Pythagoras. So now, obviously, in order for me to get this side, I'm just going to say FR is equals to FR squared is equals to F horizontal squared plus F vertical squared. Or we can just say FR is equals to square root of FH squared plus FV squared. My beautiful learners, FH is still the same as FX, because horizontally is still the same as x-axis, and then F vertically is still the same as force Fy, because of we are now vertically on the y-axis. Okay, so now let's check what is the force on the y-axis, or what is the force on the x-axis. The force on the x-axis is 15,34. So meaning here I'm just going to put 15,34 and then squared plus what is FV. FV here is 2 squared. So now let us make FR subject of the formula. I'm just going to put everything on the calculator. 15,34 squared plus 2 squared. Please press your calculator and give me the answer. Please press your calculator and give us the what? The answer. And then please don't forget to put the SI unit. What is our answer, guys? Okay, let me just press my calculator. As I'm pressing my calculator, the answer that I get there is 15,47 newtons. I hope that we understand what is going on here, guys. Please do make sure that you practice, because this topic is very easy. That's where we can accumulate more marks. That's where we can accumulate more marks. And my beautiful learners, remember that in order for you to be accepted to the university of your choice, you must be in a position of having a good report from grade 11. So meaning the grade 11 report is the one that you are going to use to apply for university. So please let us make sure that we work hard, more especially in grade 11, so that when you get your report in December, the very same report is the one that you are going to use next year to apply at the university of your choice. So my advice to you is to make sure that you put more effort on your schoolwork, more especially in grade 11, from grade 11, so that when you apply next year at the university of your choice, you do have a report that is good, so that you can get space from the university of your choice. And then this part is also going to be assessed now in your final examination. Please do make sure that you consult your educator, you consult your peers to assist you if you don't understand. Or you can also even download some videos so that you can check how to do this topic, because I do believe that this is one of the most important topic that if you can just understand it very clearly, even when you get to grade 12, you are going to work well.